we are going to understand how we can analyze uh, design the experiment, right? Analyze the data collected using the design of experiments. That too, particularly with the help of Minitab, right? So let me share my Minitab screen, and probably after I complete, if some of you would like to practice live, you can also do it. See here, I'm sharing my Minitab screen. So already I taught you the DOE basics, right? The DOE basics are taught you. So I simply believe you all know the terminologies related to DOE. So in DOE, how do we call Y variable? Y variable is known as response variable. The input variables are known as predictor variable, right? So whenever we have more than one predictor variable, then if you want to study them simultaneously, the best tool that can help you is design of experiments. So when can we go for DOE? Whenever we want to study two or more number of factors simultaneously. Because when two or more number of factors are affecting our results simultaneously, in addition to the main effect, there can also be interaction effect. You all know what is interaction effect, right? Interaction effect can be positive, interaction effect can be negative. And if there are two factors, two variables affecting our output, how many effects are possible?
इसलिए मैं रुकता नहीं था इसीलिए
Three effects are possible. If there are two factors, three effects are possible. A, B, and then AB. And if there are three factors, then seven effects are
7
possible. Out of the seven, how many are significant? And accordingly, you need to choose the optimal combination, right? So that is why we need DOE. So in DOE, we not only optimize results for the main effect, we also optimize our output considering the interaction effect. All right. Okay. So now let us take a small case study. And let's say an aircraft component manufacturing company, an aircraft component manufacturing company. They produce components, and after producing the components, they have to paint the component. And the painted component should function properly. Maybe the aircraft application. Maybe it has to, if it is an external part, then it will be exposed to very high temperature. Even if it is an internal parts, it has to what to say withstand different cycles of operation, and again there can be higher load acting. So the painted surface should have or should withstand the operating conditions. This is the requirement. So when I say the painted surface, is there a way by which we can measure the strength of the paint? Possible, right? So there is a measure known as adhesive strength. So what is adhesive strength of the paint? The force that is required to actually peel out the paint, isn't it? Once the painting is done, and again, how much minimum force is required to paint. So higher the adhesive force, obviously the higher will be the performance, functionality and performance, right? So adhesive strength is the Y variable. Please tell me, is this adhesive strength Y variable measurable? Y is measurable or not?
Measurable.
Very good. Y is measurable. So that means this is a continuous variable. Now this particular company, in order to paint the component, they use primers, right? They use primers. And in fact, there are three types of primers the company is using, P1, P2, P3. So how many type of primers are currently in practice? Three primers. Now tell me why the company is using three variants of primer instead of using just one. because they believe that there is no much difference in the adhesive strength because of the change in the primer. Yes or no? The company is using three different primers for the same component. They have three types of primer, and they used to interchangeably use whatever primer that is available. Because what do they believe? They believe that the type of primer is insignificant to the adhesive strength. When I say the type of primer is insignificant to the adhesive strength, it is null hypothesis. And this is a kind of, the flexibility the company wanted to have. If the company can have flexibility, then it is easy for them to manage the things. They can procure primer type A, type B, type C, whichever is available at a particular point of time, they can buy and then use it. So this flexibility company has been enjoying over the years, but now the time has come to study whether the flexibility is good or bad. If the flexibility is good, then they can continue using all the three primers. If the flexibility given is actually wrong, then you may have to restrict the company to use the better one out of the three. Right. So the first factor we are going to study is primers. All of you with me on this? First factor we are going to study is the primers. Second factor, the company also use two different painting methods. The painting methods are dipping and spraying. So they again, in a flexible manner, they use. Sometimes they use the dipping method. Sometimes they use priming method, assuming that what is their assumption? Both methods are in the painting method is also insignificant to the adhesive strength. Hope all of you understand. Now the output variable is adhesive strength. The input factors are primers and painting method. And for primer, how many types of primers are available? Three types, isn't it?
Three primers.
So that means there are three levels for the first factor. The second factor, there are two levels. So how many experiments we need to perform? The number of experiments. What is the formula I taught you the other day? The number of experiments, minimum number of experiments required is, what is the formula?
L1 multiply by L2 multiply by L3.
Now there are only two factors. So L1, L2 only. L1 into L2. L1 is 3 and L2 is 2, 6. And there are three important principles of DOE, isn't it? We have studied. What are the three important principles of DOE?
That is randomization,
Very good.
replication, and blocking.
Very good. Randomization,
Replication
and blocking.
And blocking.
So it's very, very important. You must replicate the experiment. So let us assume replication, right? So replication is 3. 3 means every experiment we are going to perform it 3 times. But in a random order. So number of experiments, total number of experiments will now be equal to L1 into L2 into number of replication. So 3 into 2 into 3. So 3 into 2 into 3, 18 experiments. All of you understand? 18 experiments you need to perform. You can perform all 18 experiments in just one block, or you can divide them into 9 each, or you can divide them into 6 each. If you group them into 6 each, then there will be 3 blocks, right? So whether blocking is required or not, that you need to understand the constraints and then proceed. See here, the experiment is conducted, and can you see 18 experiments here, the readings available here? Primer 1, primer 1, primer 1, And then we have primer 2. And then we have primer 3. So for every combination of primer, the dipping and spraying is also arrived. And experiments are conducted. Now you need to analyze. All that you need to do is you need to find out the best combination. You need to find out the best combination. So for that, let us create a design table first. Let us create a design table. For that, let's go to Stat, DOE, factorial, create factorial design. First of all, please understand all of you. What is the total number of experiments we require? 18. If you actually conduct all 18 experiments, then your DOE is known as full factorial DOE. Then your DOE is known as full factorial DOE. So I want to create a design for that. First, create factorial design. And the option is generate general full factorial design. Number of factors, how many factors we discussed right now according to our requirement? Only 2. Am I right? 2 factors. Then go to the design. When you go to the design, first factor, what is your first factor? Tell me.
Dipping.
What is your first factor? Primer, right?
வெங்காயத்தை கட் பண்ணணும் தக்காளி
The
கட்
second
பண்ணணும்
factor is
பச்சை மிளகாய் அழுகணும்
Painting.
painting method. And the primer, how many types of primers available?
3 types.
Very good. So 3, you can choose 3 here. And painting method, there are 2 types of painting
Two
method.
types,
1,
two
2.
types, yeah.
And number of replication, we need to have 3 replication. Do you want to divide them into 3 groups or you don't want? Suppose if you don't want to divide them into 3 groups, then perform all experiments in just a short span of time so that there are no complications. If you want to divide them into groups, then you have to click here.
I think somebody has to go
But-
on mute. So.
Yeah, I just muted Raghuram. So now, if I click here, you know what will happen? There will be 3 blocks created. That means every block will have 6 experiments. All of you are with me on this? If I tick,
Yes.
what happens? If I don't tick, what will happen? Right? If I tick,
Yes.
my experiments will be divided into 3 groups. Now it is very important that block should not have any effect on your results. Yes or no?
Yes.
So that's why, block effect is unpreferred here. So blocks must be homogeneously designed. So let me put this and then I give OK. So again, I give OK. Again, then I have to go to factors. Let me go to factors. Now, primer. Primer is a text factor. Text factor means here I can type P1. This will be P2. And this will be P3. Now, painting method is also a text factor because it's an attribute kind of factor. And one is dipping. The other one is
Right.
spraying. So now I give OK. Now I have educated Minitab on my preferred design on the factors. Now I just give OK. Now Minitab has created a design table for me. All of you, can you see a design table here? This is
Yeah.
known as, How many rows of data you are able to see here? 18.
18.
So 18 experiments you need to perform and each experiment is a kind of trial. Each experiment is a kind of trial. Totally 18 experiments, 18 experiments are conducted just to understand 6 different combinations. Yes or no?
Yes.
Only 6 combination. Out of the 6 combination, which is the best combination? That is what we want to find out. Because 3 primers and 2 painting method. 3 into 2, only 6 combination of primer and painting method are possible. Out of the 6, which is the best combination? Best combination means my adhesive strength should get maximized. Right? So 6 treatments are possible. Out of the 6 treatment, which is the best treatment? Once I understand a particular treatment out of the 6 is best, I will suggest my company to make it as a practice. Make it as a new practice. All the old belief, will be rejected, and thereafter the best combination alone will be continued. All right. So now this is done. Now what I need to do is I need to actually uh, perform the experiment, adhesive strength, so that I can get the adhesive strength. Now, what will I do? The first combination, I will take a component, apply primer 2, and then apply dipping, and that part will be tested for adhesive strength. All of you understand?
Yes.
P2 and dipping. And when I type point type 1 here, point type 1 means here we are only considering linear relationship. If you are suspecting non-linear, then you may have to type 0 here, right? So 0 means center point. 1 means end points. So this only just a kind of coding. See here, the values are also available here. Now tell me, for primer 2 and dipping, what is the adhesive strength? Primer 2 dipping, can somebody will be able to figure out here? Primer 2 dipping. What is the adhesive strength?
5.6.
5.6. So I have to, oh, sorry. I have to have the sheet. I think this one, right? This worksheet I want. Let's see what happened. This is gone.
Sir, maybe in the left side, sir.
Okay. This is one thing, and the yellow is other thing. So yellow is blank. Okay, no problem. I will anyway create it again. So what should I do? Stat, DOE, factorial, create factorial design, and general full factorial, number of factors 2. When I go to design, primer, painting method, 3, 2, and replication, you all know everything. And then when I go to factor, yes, P1, P2, P3 declared, dipping, spraying declared. Here I changed into the text factor. So I give OK and one more OK. So what happens? This comes very good. So worksheet number 3, this is okay. So now the issue is we should have worksheet 1 and 3.
Column 16.
Yeah, 1 is here. 1 is here. 3, this is 2. We don't want 2. Not required 2. But where is 3? Yeah, this one. Yeah. This is 3. This is 1. Okay. Somehow you help me. Now I want to type here. P1 and spraying. What is the value P1 and spraying? Come on. Adhesive strength, right? P1 and spraying. Come on, can you refer to the left side and tell me? Because if I touch the cursor
5.4.
here,
There is
5.4.
5.4. Once you tell me, it means the experiment is over. Right? Now, P1 spraying, similarly P1 spraying second time. Where is P1 spraying second time? That all, let us type all that so that it will be easier for us. So P1
4.9.
spraying 4.9.
9.
4.9. Thank you. Then again, I need P1 spraying
P1 spraying 5.6.
5.6. So we have conducted 3 experiments and we got 3 reading. Now let us go to P3 and dipping. P3 and dipping
3.8.
3.8. And P3 and dipping, yes, here P3 and dipping second one 3.7.
3.7.
Then
7.
P3 and dipping again, P3 and dipping third experiment
4.0.
4.0, right?
Yes.
So then P1 dipping, tell me P1 dipping, how much it is?
4.0.
4.0. Again P1 dipping here. Second experiment
4.5.
4.5. Then third experiment.
4.3.
Very good. So now we are moving on to primer 2. Primer 2 and dipping
5.6.
5.6.
5.6. And again primer 2 and dipping second run
4.9.
4.9.
4.9. And primer 2 and dipping
5.4.
here. Which combination we are going? Primer 2 and
Primer 2
Spraying.
and dipping, sir.
Dipping is over.
which one we are typing now? Primer 2
Spraying.
or primer? Are you sure?
Yeah,
P2
primer
dipping,
to
No. 5.6
P2 dipping,
and
5
4.9.
point,
Sir, primer 2, the third experiment is pending, sir. That 5.4
which means primer 2
and dipping.
dipping
Third
only,
trial.
correct. Yeah. Okay, how much it is? P2 dipping, 5.4.
4.
Thank you. Okay, now I move on to P2 spraying. Tell me, look at the left side table and tell me P2 spraying.
5.8.
5.8.
5.8.
Again, I need to look for P2 spraying. Now
6.1.
6.1
6.1 and one
and
more
6.3.
6.3.
6.3. Now finally P3 spraying. P3 spraying
5.5.
5.5,
5.
5.0.
5.0.
5.0.
5.0, right?
Yeah. Last
Okay,
one
and
also
final.
same.
And
Very good.
5.0 also.
This is how you need to actually conduct the experiment. See, there could be some variation here. I want you to understand. Are you able to notice some variation here? When we repeat the experiment, a small variation is coming.
Yeah.
You can't say, the variation is nil. It can be because of the uncontrollable factor, or it can be because of some error in your experiment. All of you agree with me?
Yes.
It can be when I repeat the same experiment, when I get different reading, the variation can be because of the uncontrollable factor known as noise factor, and the effect is noise effect, or otherwise some error within our experiment. That means that variation we are not able to understand. Always we should know our limitation. Whatever we are not able to understand, whatever is the limitation we have in our study, this is what can cause us to commit type 1 error. Yes or no? So we are
Yes.
going to actually estimate that and then do that. So now we have all the things table created. Now let us go to stat, DOE, go to factorial. Now you can analyze the factorial design. Do you notice the steps? Stat. Earlier we created the factorial design
Design.
and then we performed the experiment. And then we actually, noted down the readings. And now with the readings, we are going to analyze. And now please tell me what will be the kind nature of analysis or the type of analysis we'll be performing now. The output variable is continuous and there are 6 types of treatment. Which is the best treatment? This is what I want to understand. Can you understand this is a kind of ANOVA test, isn't it? ANOVA means we are comparing 2 or more number of groups with the output variable measurable. Our output variable is measurable, adhesive strength.
Yes.
So now the analysis narrows down to an ANOVA. But Minitab will do everything for you. So I clicked the analyze factorial design. Now Minitab is asking me to declare the response variable. The response variable is typed in the column number 7. So I click and select. Now what are all the effects you want to study? For that, you have to click the terms. And since there are 2 factors, right? There can be, if I click 1, I'm considering only main effect. Can you see here? Effect of the primer, effect of the painting method.
Yeah.
But when I click 2 here, in addition to the main effect, the interaction effect is also included. The interaction effect is also included. And include block in the model. If I include block in my model, my requirement is block should not be a factor. If you don't want block to become a factor, then the corresponding p-value for the block must be more than 0.05. If the p-value for the block is going below 0.05, that means you have a problem in the way you blocked, right? That you need to understand. Anyway, let us see what the result says. So give OK, and then you can give one more OK. And now the job is done. Now see here, the result has come. In just click of the buttons, everything is happening. What is the heading? General
Factorial regression.
factorial regression, adhesive strength versus primer
Block.
painting method. You see here, blocks also included. Because there is a chance, if you poorly block your experiment, then block will also become a factor and the confusions, can go on, can go high. All right, now the factors, one is primer. There are 3 levels, P1, P2, P3. And painting method, there are 2, dipping and spraying. And now ANOVA. You see here, what is the heading here? ANOVA, analysis of variance. Why ANOVA comes here? Because my output variable is continuous. And how many type of treatment I am comparing? 6 type of treatment. Out of the 6, definitely one combination, one treatment is the best, which I want to choose and recommend to my company. Now, see here, blocks. What is the p-value for the block? What is the p-value?
0.3. 0.33.
3334.
4. Is it more than 5% or less than 5%?
Less than 5.
Is it more than 0.05 or less than 0.05?
More than 0.0.
More than 0.05. That means more than 5%. So blocking is done properly. All of you, do you understand how do we infer from here? If blocking is done properly, your p-value will appear more than 0.05. Otherwise, this will appear less than 0.05. Now, what is your conclusion about the blocks you formed? It is okay, acceptable. Clear, all of you?
Yes.
Blocking is done properly. A fair way of blocking is done. Now, you assumed linear model. You assumed a linear model. See here, you remember I used the word linear, right? Right? No
Yes.
x square, no y square required. No x1 square, no x2 square. Only x and y are required, or only x1, x2 are required. So linear model. And here the null hypothesis is there is no linear relationship. Alternate hypothesis is there is linear relationship. Now look at your p-value. What is the p-value here? For
0.
linearity, 0. That means less than 0.05.
Yes.
So there is no linear relationship. That null must be rejected. That confirms what? There is linear relationship between your x factors and y factors. Clear, all of you? Your thinking in terms of the mathematical model is correct. The way you blocked your experiment is also correct. Can you see that, all of you, happening? How are we understanding everything? By looking at the corresponding p-values. Then now we go to the factor level. First factor, primer. Look at the p-value. What is the p-value here for primer?
Sir, can
0.
you repeat for linear? What is
Yeah.
null hypothesis and alternate?
Yeah, for linear, I can even write here, null hypothesis is there is no linear relationship. Always your null hypothesis must be written in this manner only. You remember we started like that only, isn't it? There is no linear relationship. There is no impact. But p-value is going below 0.05. That means what? There is linear relationship.
Relationship.
So relationship is understood. Relationship is statistically proved. And so we are going to understand relationship is linear. Now coming to the next one, primer. What is the null hypothesis here?
0.
Primer
P-value is
effect.
0.
Primer effect are equal. I need to mute. Please keep your background noise free. Otherwise, I will have to mute you. See how I have written my null. Primer effect are equal. Because how many primers you have?
3 primers.
3 primers. All 3 primers, if they give equal effect, I can use any of the primer.
Yes.
That is what company is currently following. So primer effect is equal, but look at your p-value. What is your p-value? Below 0.05 or more than 0.05?
0.
Below 0.05.
Below 0.05.
That means company's belief is wrong. You have to reject the null hypothesis. You have to tell your company that they can't have flexibility with respect to the primers. Definitely, there is a significant difference in the effect, right? Because of the type of primer. So whichever effect is good for your product, that primer only your company should use, not simply any of the primer that is available. All of you understand this? So you have to now boldly give a recommendation for your company to eliminate the current flexibility. Whichever out of the three primer, whichever is good, now you refer the data and find out which is good. That is easy job, yes or no? You go to the reading because you conducted reading. You have 3 readings for primer 1. You have 3 readings for primer 2. You have 3 readings for primer 3. Now try to find out which primer is giving you a better strength. That should be the decision. Now if primer 2 is good, primer 1 and 3 requirements must be stopped. You don't have to require 1 and 3. Hereafter, order must be placed only for primer 2. All of you, do you understand how are we making decision here? Now, going to the painting method. Painting method, there are 2 types of painting method. And so here, what will be the null? Can one of you tell me? What will be the null here?
The painting methods are equal. Maybe.
Dipping and spray
There's
same.
no difference.
Okay.
Dipping and spraying is same. Both are
The
equal.
effect of painting method are equal. Very good. All your statements are correct. But again, the p-value is less than 0.05. So this null is also getting rejected. Can you see all your null hypotheses are getting rejected? That means there is linear relationship. That means primer has got a significant effect. That means painting method has got a significant effect. And now interaction. Let us go and check the interaction, two-way interaction. There is only one two-way interaction, which is primer and painting method. Here, what is the null hypothesis? Interaction effect is insignificant. Interaction effect is insignificant. But look at your p-value. P-value is less than 0.05 or more than 0.05.
More than 0.05.
That means, will you be able to reject your null?
Yes.
Fail to reject null.
Fail to reject the null.
Fail to reject null. That means interaction is insignificant only. You don't have to think in terms of the interaction here. But main effect is significant. 2 main effects are significant and the one possible interaction effect is insignificant. So don't worry about interaction. But definitely your decision must be based on main effect. Clear all of you? Now look at your model summary, quality of your thinking. Quality of your thinking. Look at the R square. How much it is? 92.6%. You included 2 factors. You considered linear model. So if I include 2 factor and consider linear model, my data is fitting to a maximum extent. That is why it is 92.6%. Do you understand? But the better R square is adjusted R square. Adjusted R square. Adjusted R square is also not too bad. This is 92. This is how much? 87. So 87.43 because one of the interaction factor is insignificant. Yes or no? So that insignificant factor we are not going to consider. So there is a slight drop here. Adjusted R square is 87%. See, this is just confirming you that you are thinking in the right direction. You are thinking, you are including right factors. You are connecting them in the right manner. Yes or no? Then only all these values will be at the higher level. At least if they are 80% and above, that is very good for you. So now, okay. So now this is actually the regression equation you see here. This is the regression equation. But here, regression equation will be very much helpful if you work with a continuous predictor variable. If you work with continuous predictor variable. What is continuous predictor variable? Let us say temperature, boiler temperature, 600 degrees Celsius, 700 degrees Celsius, 800 degrees Celsius. Now, which particular temperature is suitable for my boiler? 675 degrees Celsius is suitable. In order to find out the exact temperature, you can use the regression. But here, even though the regression equation is available, you just limit your thinking to understand the model summary. Enough. Because you are going to take a call out of the 3 primer, which is the best primer. That is what you want to understand, yes or no? It's not a continuous variable. How many values are possible for primer? Only 3. Out of the 3, which is good. Similarly, painting method, how many methods available? Only 2. So we really don't want to go for the mathematical equation to understand, but the quality of our thinking and decisions we are able to just judge here. And now, in order to understand whether primer 1 is good or 2 is good or 3 is good, similarly whether painting method dipping is good or spraying is good, and here the number of experiment is manageable. Only 18 readings, isn't it? If you got a very good eye, you can simply read from here. But I'm not going to read in this manner because even 18 readings, this is very, what to say, very tiring. So I wanted to visually represent. I want to visualize the data so that I can take a better call. So for that, I go to graph. Then I go to line plot. I go to graph and then I go to line plot. Now, how many y variable we are trying to optimize? Only one y variable. What is that y variable? Adhesive strength. So click that and then give OK. Now, how many treatments are available? I told you 6 treatment. Every treatment will give a value of adhesive strength 3 times. Yes or no? Because every experiment we performed thrice. So many statistics are given here. Which statistics you can use? Average of the 3 values you can use. What is the average adhesive strength for each type of treatment? How many averages you will have? 6 averages. Yes or no? Out of the 6 average, which is the best average? That is going to be the best combination. Now, graph variable. Graph variable 1 is graph variable is adhesive strength. Yeah, graph variable is adhesive strength. I double click. Then categorical variable, that is X variable. One is primer, then other one is painting method. So I have considered 2X and 1Y and I am giving OK. And now I get a graph line, which is known as line plot. Sometimes people call it as interaction plot. All of you, can you see the graph here? One red color graph, one blue color graph. The red represents what? Spraying. The blue represents what? Dipping. So this y-axis represents adhesive strength. So which type of painting method is giving you the better adhesive strength? Red or blue?
Red. Spraying.
For all the combinations, all the 3 combinations where red is used, the adhesive strength is on the higher side. Can you see that? Similarly, primer 1, primer 2, primer 3. Primer 1, there are 2 averages. Primer 2, there are 2 averages. Primer 3, there are 2 averages. Out of the 6 dots, each dot represents an average here. Each dot actually represents the average adhesive strength. Out of the 6, which is the best average? Because we want the maximum here. Maximum means I can pick up this, yes or no?
P2 primer.
So
Primer
primer 2 and spraying is the best combination. This you can understand by reading from the data also or reading from the graph also. But reading from the data sometimes is difficult. If you have, let's say, several thousand data points, it's not that easy, isn't it? So this graph is very much helpful. So what is your final conclusion now? Tell me. you will decide to
Using
we should
using
go for
primer
And,
two.
Tipping.
and doing by spraying.
you will decide to buy only primer 2 and use only spraying method. Even though the
Spraying method.
dipping facility is available, you have decided not to use it. Even though you have suppliers who can supply primers of type 1 and type 3, you have decided not to buy from them. But this was in practice for several years in the past. But after this study, we have decided to proceed only with primer 2 and adhesive strength, primer 2 and spraying. So what will happen? The adhesive strength will be always on the higher side. That means the customer complaints, the chances of customer complaints will certainly go down significantly. Yes or no? Because the paint quality is improved. Can you see that? The chance of failures are minimized. Yes or no?
Yes, sir.
Yes.
So this is one example of DOE known as full factorial DOE. Can any one of you, will you be able to repeat this if you have to do it yourself right now? Anybody having I will step by step, I will guide you. Who want to make a try? You can share your screen and then you can share your Minitab screen, because I already shared the Excel file also and the Minitab trial version also you all have. So who want to try the same problem by yourself now?
I'll give it a try, sir.
Yeah. So I'm only asking you to try. Yes.
Okay.
Please share your
Let me
screen.
share my screen, sir.
Yeah, I will enable. Yeah, I have enabled the screen sharing.
Okay.
So whatever be the factor, you should be able to create a table, and as per the table, you conduct the experiment and then proceed. Okay. Good. You have the, what do you call, Minitab now opened. Now, what is the first step we should do? Create a factorial design. So start
DOE,
DOE
factorial,
factorial,
create
create a
factorial
factorial design.
design.
Now you have to choose full factorial. See, after learning full factorial, you can explore the other methods. And now number of factors in our case is 2. Then you go to design. One is primer. Oh, already you have typed ready-made. Primer, painting method. There are 3 primers. There are 2 painting method. Number of replication is 3. You have done blocking. Okay. Now click factors. And what is the name of the primer? And you don't have to make it numeric, because this has no meaning, right? If it is a measurable variable, then you can put it. It is actually text only. So 1, 2, 3 means P1, P2, P3. You better type it, change it. P1, P2, P3. Just to place your cursor on 1 and make it P1. Yeah, it's more illustrative. P1, P2, then P3. Similarly, painting method, you can say dipping and spraying. Okay, dipping and this is spraying. And now that you have designed your thing properly, now you give OK. Now you will get the randomized run order. Can you see here? 18 trials you need to perform according to the order recommended by Minitab. This way we are respecting a principle known as randomization. Randomization is respected. Blocking is also done according to the requirement, because blocks has to be homogeneous. When you ask Minitab to do it, it will apply all those principles, and based on that only it is created. Now, in column number 7, you have to type your experimental reading, which is adhesive strength in this case. You type adhesive strength. Okay. So now the readings are required, right?
Yes, sir.
Okay. So readings. So, okay, I will tell you, you need to type, right? So P1 spraying, 5.4. Can you type?
Yes, sir.
Actually,
P1
sir, in your Excel sheet, there is actually not that
No,
reading
it's
table.
available.
All
It is
result table.
available, but if you copy paste, it won't accept. If you copy paste, Again, Minitab will ask you to declare. Because whenever you perform DOE in Minitab, you have to feed the value in the template created by the Minitab. Do you
Okay.
understand what I'm telling? If you have the same format available in Excel, even if you copy paste, it won't accept. It has to be redefined. Anyway, Palnivel, you can type the value. P1 spraying 5.4.
Yes, sir. Done, sir.
Then same P1 spraying second time 4.9.
Should I
Are
type
you
it?
able to get it?
P2 spray?
Oh, P1 spraying only I'm telling. First value 5.4, second value 4.9.
Right.
Got it?
Yes, sir.
Then third value, P1 spraying 5.6. One combination is over. Okay?
Yes, sir.
P3 dipping 3.8. Second reading 3.7. P3 dipping. Are you typing?
Yes, sir.
Third reading P3 dipping 4.0.
0.0. Yes, sir.
Yeah. Now the third one, P1 dipping. Third
Yes.
treatment, P1 dipping 4.0.
Okay.
And again P1 dipping 4.5. One more P1 dipping 4.3.
P1.
4.3.
14 series. 14.
P1 dipping 4.3, I said. P1 dipping, last reading 4.3.
Done, sir.
P2 dipping 5.6. P2 dipping 4.9. And the
4.9.
last one, P2 dipping 5.4.
Last.
5.4. Yes, sir.
Okay. Then the fifth combination, P2 spraying.
Yes, sir.
First value 5.8. Second value 6.1. Third value 6.3. Done.
Yes, sir.
The last combination, P3 spraying
Yes, sir.
5.5. First reading.
Okay.
Second reading 5.0.
Yes, sir.
Third reading also 5.0. So which means you have performed all 18 experiments. Now you got the readings,
Yes, sir.
right? Now you can analyze.
Need to go to stat, DOE, factorial. This time we need to click on analyze factorial design, right?
Correct. Now your response variable you select. Yes, click and select. Now what are the terms you want to include in your model? Terms means the effect. I want to include main effect as well as interaction effect. So one means two main effect will be included. Two means in addition to the two main effect, interaction effect will also be included. Whether it is significant or insignificant, it will appear in your model. So all that you brought it, now you can give OK. And you can give one more OK. Your analysis is over. Now, if you go to the ANOVA table, you should be able to comfortably understand what the ANOVA analysis is telling you, right? So come down. Yeah, this is the ANOVA analysis of variance. Wherever p-value is less than 0.05, what is the meaning? Wherever p-value is more than 0.05, what is the meaning? And with respect to the block, what is our requirement? Our blocks must be homogeneous. Homogeneous means equal. Equal means there is no difference in the effect. So p-value coming higher is means very good. So leave it. And coming to the linear model. Linear model, p-value low means linearity is significant. Linearity is significant. And then primary effect is significant or insignificant? Primer effect is also
Significant.
significant. And the painting method effect also significant.
Significant.
But the interaction effect, insignificant.
Insignificant.
So no worries about interaction. You only choose the best primer, choose the best painting method, and then take a decision and implement it.
Okay.
All of you are with me on this. And how will you plot the line plot also? Plot the line plot just to visualize the graphs. Graph, line plot. Come down, line plot. Yeah. And the first one, yes, okay. And already mean is selected. Graph variable, what should be your graph variable? Adhesive strength.
Adhesive strength.
What is your 1x variable? One categorical variable is primer, which will be taken in the x-axis. Then the legend will be other x variable, which is painting method.
Painting.
Painting method. And now the entire data, that's enough. You can give okay. Now the
Okay.
entire data will appear in the form of a graph. Now it is much easier for you to decide. See
Okay.
here, the lines are going parallel to each other. Have you noticed?
Yes.
This is a visual confirmation that there is no interaction. There is no interaction. If interaction is there, you will see the graphs crossing. The graphs are not crossing parallel. That means it's a visual confirmation. So mathematics is giving you a lot of information actually, which when you actually practice, you will be able to understand many things from your data, many things from your graph, and which all those information will be helpful in making effective decisions in your business.
Yes.
Clear, all of you?
Yes, sir. So there is a particular delta, sir, between dipping and spraying method
Yes.
with respect to
There is,
adhesive.
yeah. There is a
Delta.
Yeah, correct. Here, the spraying is giving you significantly higher adhesive strength, and primer 2 is also significantly giving a better effect. So my conclusion is going with this combination, and hence the problems can drastically come down. So now tell me here, suppose if you have a similar scenario of y variable and 2x variable, can you tell me some other scenarios now? Let all of us have a little brainstorming. Let's say you are a chemical process industry, right? The chemical process yield is the response variable. And one type of X variable is the formulation, right? The composition, 2, 3 composition exists. So the formulation is one thing, and chemical reaction temperature can be another factor. So chemical reaction temperature, different values exist, and your formulation 2, 3 levels exist. And what is the chemical process yield? You have to understand your y variable, understand your x variable, understand the range of investigation, choose the appropriate values, right? If you choose three values, then the level is 3. If you choose only 2 values, then the level is 2, right? Accordingly, you create the design table, conduct the experiment, perform the analysis, find out at which particular combination the yield is getting maximized. All of you are with me on this?
Yes, sir.
And there is no limit. Wherever you have an output variable and input variable, where you want to optimize your output for various combination of input, DOE can come and help you. And all these calculation, I really don't recommend you to do it manually. Better use these templates, because those steps are like, too much of mathematics, which only if there is a requirement, I will suggest you to understand it. Otherwise, not required. Am I correct? What is the point in just simply doing all those mathematical steps manually Because nowadays tools are available. That intelligence is already available in the form of a software.
Yes.
And this is what people call it AI, isn't it? AI powered Six Sigma. So you can also be AI powered nowadays. Now being AI powered is appreciated nowadays. So you don't have to really stress your brain too much. Rather, you can just interpret the information.
Yes.
Sir,
Okay,
only
so
we have to in this only we have to type all the output values.
all the our output variable is only one. Our response variable is always only one. But input factors can be many. And you can simply have all of them in, you declare, Minitab will create a table. And as per the table, you conduct the experiment. Then feed the data. The same manner you do it, whatever be the number of factor, but accordingly, the complications in your ANOVA table can increase. There can be 2-level interaction, there can be 3-level interaction, right? And sometimes your mathematical model, whatever model you assume, suppose you assume a linear model and then the p-value is not going below 0.05, then what will happen? You have to change the model.
Mm.
That you have to declare, right? So those slight complications will happen if you are actually dealing with the different scenarios. Let's say, for example, attrition rate. Attrition rate is a major problem in many companies. The HR executives are responsible for bringing down the attrition rate. What are all the factors that can influence the attrition rate?
Salary,
Salary.
Results are known.
Salary level.
work
Salary
culture,
level, and how many categories of salaries a company might have?
Number
High
of
salary, medium salary, low salary. And
according
some
to
people very high
position.
salary, very low salary. That means different levels. Can you see that? And
Right,
what
sir.
other factors can affect your attrition in the company? Age,
Working hours.
working hours, shift factor, isn't it? If you continuously expect certain people to work on shift, then probably after 6 months, after 1 year, they tend to resign. And similarly, whether the family status of the employees, whether they are bachelor or married. Do you really want to study all of these things? Sometimes, right? You
Yes.
have plenty of data, but you don't know, you really don't know whether the factors are really influencing your result. Yes or no? All that you need to do is put the data in the appropriate format and then perform the analysis and look at the p-value. The p-value is going below 0.05 and you understand the bachelors tend to resign so frequently, then you can adjust your policy. What is the policy? Only married people or people having minimum 5 years of experience will be appointed for certain position. Because your data says the bachelors, they tend to resign very quickly.
Correct. Mm.
So this way, the analysis can go on hereafter. If data is readily available, use that data. Like right now, I gave the data, isn't it? Palnivel was simply typing whatever data I'm telling. But here the belief is data is clean and credible. Garbage in will be garbage out.
Yes.
If data is
One
not
more thing, sir.
available or you are not sure about the quality of the data, then you have to perform experiment and then collect the data and then do it. So HR people can use DOE, chemical process industries can use DOE.
Yes.
And in my example, it's a kind of aircraft component manufacturing company. They can use DOE. And can we as a training agency, can we use DOE?
Yes, sir.
Can we use DOE?
Yes.
So whether conducting these kind of extra sessions are really helpful, is it really even enhancing the customer satisfaction? We don't know, isn't it? Some people might feel it as a torture also. What is this? We just wanted joined here, but then these people are taking class even in the late night, midnight. So we don't know what happens. If you don't know, then you have to look at the data. If you are very, very clear, then you don't have to unnecessarily complicate the situation. Proceed. But whenever you are in doubt, yes, refer to the data. And that data must be clean and credible. Clear, all of you? DOE, now you got some idea, right? Definitely, hereafter,
Yes.
DOE may not be a very troubling kind of tool for you. But any
Yes, sir.
DOE will finally narrow down to a simpler level of analysis. Most of the time, it is ANOVA. Most of the time, it is ANOVA. Okay. Now, can any of the participant, would you like to share a situation where you can use a
Uh,
similar tool, DOE?
Not really situations, sir. Only few doubts, sir. May I ask, sir?
Okay. Yeah, please.
Yeah. One doubt is that because with respect to replication, so here we have used the 3 replication. So we can use
Yes.
the 2 also and 4 also. Correct, sir?
Correct.
Accordingly, the number of experiment will be going to increase and decrease. This is
Yes.
the one point. And second, sir, here the ANOVA where we have to use the ANOVA we used when Y is continuous and X is decrease, and there is more than 2 groups where we have to compare.
Yes.
But the point is that, sir, but here there was 2 group only. One is the primer and other one is the method. It was not
Hmm.
more than 2.
But why ANOVA, right?
Yes, sir. Why ANOVA?
I have explained it already. It's not just to do. There are 6 combination exist.
Okay,
Each
sir.
combination of your factor and level is known as treatment. 6 types of treatments exist, isn't it, in our discussion? Even though we
Right.
talk about primer and painting method, there are 3 types of primer and 2 types of painting method, and totally 6 combinations are possible.
Right.
So we are trying to find out the best out of the 6. So it is
Yes.
ANOVA. Suppose if you really come across a scenario where there are only ANOVA only. ANOVA is meant for finding out the best out of 2 or more number of groups. Not only more than 2 groups. Even for 2 groups, you can use ANOVA. Clear?
Yes. Clear, sir.
Good.
And last question, sir. Last question, sir. So here we
Yes.
have called this full factorial. So why
Yes.
we call full factorial? Because we have considered all the factors. Right, sir?
No, we considered all the factors and we actually conducted all the experiments.
All the
All the
times.
experiments. So there was
Sometimes this,
yes.
yeah, please go ahead.
So, sir, I heard I studied somewhere that there is a one factor at a one time also. That
That
one
is
factor.
hypothesis testing.
Okay.
That is hypothesis testing. Start thinking only about one factor. Forget about all other factors. Thinking about only one. But here we purposely considered all significant factors simultaneously. Why? Because we are now educated a little more better. We know interaction can also affect.
Correct, sir. Correct.
So since we are able to think better, we are also know what to say. We are also designing our experiments in a better manner. Okay.
Right. Thank you, sir.
So here in full factorial, we normally conduct all experiments. If there are 18 experiments possible, we actually conduct all 18 experiments. Suppose if one experiment is, conducting one experiment is 2 lakhs. The cost of one experiment is 2 lakhs. Then in that case, 18 experiments may not be possible. So probably I may not conduct certain experiment which may not be that much helpful, may not be providing you a very meaningful information. So certain experiment I will exclude. Why am I doing this? To minimize the experimental cost because it is too costlier. Yes or no? So when I don't conduct some of the experiment and conduct only a part of the experiment, then my DOE will be partial factorial DOE. Only the terminology. Partial factorial DOE. Suppose if I don't conduct half of the experiment, there are 18 experiments I only conduct 9, not the remaining 9, I skip. Then my DOE will be half factorial DOE. Partial factorial, half factorial. Sometimes what happens, if there are, let us say there are 5 factors, each factor at 3 level, and then the number of replication also 3. Now what will be the total number of experiments? Tell me all of you. 5 factors, each 3 level, and number of replication also 3. Now what will be the total number of experiments?
45.
45.
Really? Just 45. 5 factors, each 3, right? So 5 times 3.
15.
Yes or no?
15. Yes.
5 times 3 itself 243. And replication also 3.
Okay. That's
So total number of experiment is how much? 729. So many experiments, isn't it? And so whenever the number of experiments are too high, and if the cost of experiments are too high, you need to narrow down your experiment in using some logical manner. Either you make it as a partial factorial DOE or a half factorial DOE, or otherwise there is one other method known as Takeuchi design. By learning this design, you can actually cut down your cost incurred. You can reduce the time incurred, and then you can reduce the effort required, but still you arrive on the best possible conclusion. And these extra methods, yes, you need to learn, because actually in a real-time scenario, it is not always possible for you to conduct a full factorial DOE. Whenever you wanted to simplify and perform only certain number of experiments, then you may have to switch to the other methods. So I would like to educate you on the advanced methods when we meet for the next level. Meanwhile, I've shared some good books. You can read and understand. Okay. All the very best. This is about the DOE.